Okay, so for lesson 1-6, you had a chance to work on your review questions 1 through 5. So the congruent marker is this last picture down here. The point is, I think most of you will agree, is that one. The ray, again, has an endpoint and extends in one direction infinitely, is this one right there. And then the last two are kind of iffy. The vertex, well, this is showing just the vertex of that angle. And then that looks like a vertex of 4 angles. But if you look at number 5, it wants the intersection of segments. Well, that quite obviously is not the intersection of segments, that is. So based upon process of elimination, this has to go to 5, and this has to be the vertex. Then we have a new vocabulary word, which should go on a flashcard. The new vocabulary is perpendicular. Typically, we think of perpendicular as 2 lines that intersect at a perpendicular angle. Perpendicular means that typically 2 lines intersect at a right angle and they create 4 right angles. But this is bringing about the fact that perpendicular means right angles to a given line or a plane. So you can have 2 planes that are perpendicular to each other. They create a right angle, just like a wall can create a right angle, or 2 walls can create a right angle. Or 2 intersecting lines that create 4 right angles, or you can even have a line that's perpendicular to a plane that creates a right angle. So any of those are acceptable. A non-example would be an acute angle can never be perpendicular because by definition it's less than 90 degrees. An obtuse angle can never be perpendicular because it's greater than 90 degrees, although it can include a right angle. Straight angles, by definition, are not perpendicular because they equal 180 degrees. Although, as you can see, if this is a right angle here, there would be a straight angle containing 2 right angles. But the straight angle itself is not perpendicular. Then question 6 is asking you which of the pictures shows perpendicular segments. Clearly, the first picture must be the answer. Flip it. And today we are going to make some basic constructions. So the first construction, they want you to come up with the steps that this student has used to construct a line segment that is twice the length of the original segment XY. So instead of having you guess, I'm going to have you write them down because it makes more sense to have you write them down. And then, oops, picture. Well, I'll come back to that. That is the picture I want up there. And then I'm going to show you how that student came up with these particular steps. So the first step they did, they just drew any segment XY with a straight edge. And then we need to create another segment that's twice that length. So they just created a ray. You could have drawn a line segment, it doesn't matter. But they chose to do a ray rather than a line. And we're not ready to actually, you can make that line as long as you want to make it fairly long, definitely much longer than that one, and then put that endpoint R. Then the second step was to draw an arc with your compass point. So all they did was take this measurement. So they measured that distance with their compass. They put one end of the compass here, the other end here, and made an arc. And then came down here and made that same arc here, and you can see me making the arc measurements there. Then they did it again. They put one end of the compass here and the other end here and made a second arc, creating one segment that's XY, another segment that's XY, so the whole distance from here to here would be 2 XYs, and there should be a line segment right there. And then finally they labeled this last point here as S. So you want those steps written down. Then for problem 2, we are actually going to create an angle. So we have angle B here, but we're going to construct angle F so that angle F is twice what angle B was. So here we go. You've got some steps here, kind of like a flow chart. I want you to fill in the steps before we actually construct the angle. So you're first going to start and use a straight edge to construct the ray with endpoint F. Then with your compass, point on vertex B, draw an arc that intersects both sides of angle B. Label the points of intersection A and C. Then you're going to use the same compass setting, which I'll explain here in a minute. Put the compass point on point F, draw a long arc, and label its intersection with a ray as S. So then step 4, open the compass. Well, we use safety compasses here at Horizon, so you won't open your compass, you'll just measure a particular length. So open the compass to the length of the distance from A to C, which will be from here to here. With the compass point on point S, draw an arc, which I'll demonstrate. Label the point where this arc intersects the other arc as point T. Step 5, use the same compass setting, put the compass point on point T, this is the point we got from here, draw an arc, and label its intersection with the first arc as point R. And then finally you'll draw ray FR. So, here we go. So we're going to start off with step 1. We are going to use a straight edge, and here's what a safety compass looks like, and what's nice is that they have a straight edge on them. So we're going to draw a long ray, and it has endpoint F. So then step 2 says, with your compass point on vertex B, so here's vertex B, I'm going to put a point right there, draw an arc that intersects both sides of the angle. So it doesn't matter the length of your arc. Because this is a small picture, I normally like to use the orange part, but I'm going to just choose any one of these holes in here to create a small arc. So I'm just going to choose this particular setting here. So it's the top third hole, and I'm going to draw an arc through, and then label those points, which are already kind of labeled here for me, as A and C. So that's the same distance arc that I want to put on F. So on F, if you didn't keep your compass in the same hole, you can go back and recheck it. But I use this top third hole. And so I'm going to hold on to the orange part and create a pretty large arc, because I'm going to go twice as big. So a fairly large arc here. And they want you to label this as point S, as in Sam. So now we have to create an angle that opens up twice as big as this one. So in order to do that, I need to measure this distance from A to C, and that's what step 4 is asking me to do. So we're going to measure the distance from A to C. Again, it's a small distance, so you're going to be using the white part of your safety compass, and one of these 2 holes is going to line up with that point you made on C. For me, it's the lower second hole here. Get my red back in the right spot. So as you can see, it's this lower second hole right there, for me. For you, it might be different. So now I'm going to keep that setting in my compass. Don't lose it. I just did. Let's find it again. Lower second hole. So pick up the compass. Put your brad on S. Keeping that compass setting, holding down the orange in this case, and you're just making an arc right here. So I'm going to keep my pencil in that hole, and we're going to mark this point right here where it intersects with that original arc as point T as in Tom. So this is actually going to create, if we were to stop here and put a ray from F to T, that would be a congruent angle. But we want twice the angle, so we're going to take the same measurement, take my brad and put it on T this time, holding on to the orange, and I'm going to create a second arc on that first arc and call this point, I want us to call it point R. And then finally, I can connect with a straight edge, F to R, and this should be twice as big. So if I take a protractor to measure, so I'm going to put the middle of my protractor on B and line up BC, ray BC with the 0 line on my protractor. So I don't want it looking like that. I definitely want the line to line up here nice and neatly. Then take your compass and extend out this ray, because the ray is short. And the original angle was 40 degrees. You can read it here on the inside, right here, 40 degrees. So that means that this angle should be 80 degrees. It's definitely less than 90, so that's a plus. And you might be a couple of degrees off, which is okay. And then if I extend this, make sure I'm up where I'm supposed to be. If I extend this, you might be within, anywhere from 1 to 5 degrees off is possible. And so right here is my 80, so I am about 3 degrees off. But that's okay. It's close enough for our work here. Good enough. Now, if we had actually measured, let's go back and measure here, our original first angle that we made, 3T. So if I put an arc 3T right there, because I'm about 1 degree off there, it makes sense that if I'm going to increase that, the bigger I make my angle, if I'm already a degree off in my original angle, then I'll be 2 to 3 degrees off on my next angle. But anyway, that's close enough for our work here. All right, so flip that. Then the next question asks, circle the drawing that, let's look at the next vocab. We have 2 vocab words here. So perpendicular bisector should go on the flashcards. It's essentially, it can be a line of segment or a ray that is perpendicular to another segment at its midpoint. And so here are some examples of which one of these would represent a perpendicular bisector. Well, all of the things that are being cut are segments, which it has to be a segment. You can't cut a ray or a line because they have an infinite side to them. So how long is that? Hard to tell. This one is perpendicular, but we have no tick marks showing that from A to the bisector and from the bisector to B are equal. So we cannot assume that those pieces are equal. So not that one. This one bisected the segment AB, but EF is definitely not at a 90-degree angle to AB, so not this one. But this one has both pieces. Not only is it perpendicular, EF is perpendicular to AB, but it's also, the tick marks here are showing that AB has been cut into 2 equal pieces. So perpendicular bisector has 2 parts to it. It's perpendicular and it bisects. So the name itself tells you what the definition is. So we're going to construct a perpendicular bisector. In problem 3, they want you to tell what the child did wrong, but we're just going to go ahead and construct one. They're pretty easy to construct. So step 1 would be just construct any segment. And actually, let's measure your segment. Let's make this one 6 centimeters. So I want from 0 to 6 centimeters. So put endpoints on here, and we're going to call this A and B. We want to cut that in half, and we want to create a perpendicular bisector to that. So the easiest way to do this is to take your compass and measure starting from the left. Hold on to that brad. So I put the brad over A. I'm holding on to it. Make sure it's directly over A. I'm holding on to that brad. I want to create a distance on my compass that is more than halfway. If I go less than halfway, I'm going to create 2 arcs, one on either side. They're not going to intersect. If I go exactly halfway, that's hard to do. We want to go more than halfway. So I'm going to choose, probably this point right here. And remember that point. So I'm going to create a very large arc that covers over the top and the bottom. Don't necessarily go into the circle. That's not really what we're looking for. Keep your pencil in that hole, and then just move the brad up a little bit over to B. And with that same setting that you used at A, hold on to B. Create another arc until it intersects with the first arc. So you should have 2 X marks the spot. So I have a point here and a point here. We'll name this point C and this point D. And then use a straight edge to connect the 2 points. And so this should be perpendicular here, so let's measure it with our protractor. See if it's 90 degrees. And sure enough, If I extend out my compass, it's right there at 90 degrees. So that was a perfect perpendicular, two perpendicular lines. But then we need to check to see if this was bisected. Remember, the original line was 6 centimeters. So the distance from A to the perpendicular bisector should be 3 centimeters, and indeed it is. So that means that this side is congruent to this side. So that one's a pretty easy one to make. And then for 11, they want you to bisect that. We just did it above. We're not going to do it again. And then the last page is an angle bisector. So that means we want to take this angle and cut it into 2 equal pieces. So this one's actually easier than doing a congruent angle. So let's go in the directions. Put the compass point on vertex Y. Draw an arc that intersects the sides of angle Y and label the points of intersection A and B. So we'll do that in a minute. You're going to put the compass point on point A and draw an arc with the same compass setting. Draw an arc using point B. Be sure the arcs intersect and label the point where the 2 arcs intersect as P. And then you're going to draw ray YP because that is your angle bisector. So here we go. So very first thing, take your compass, and just like we did when we were measuring a congruent angle, we took the brad and put it at the vertex of the angle, in this case Y, hold on to that. Then look over here at the side of your angle and choose, well, this is a pretty small angle, so choose the smallest, I'm moving my point here, choose the smallest setting that you can here, and we're just going to create an arc. Move this down a little bit, create an arc. Oh, yep, that worked. That worked. So I created an arc, and all I did, it got messed up with my mistake. That's why. So I just created an arc there, and it intersected here at points A and points B. I think that's what they wanted us to label it, right? Point A and point B. Then from those 2 points, so you can ignore the X and the Z, from those 2 points, we are going to create, and it does not have to be the same setting yet. We're going to create from A, pick a setting that's going to bring you out somewhere here in the interior of this angle. And so I think I'm going to choose different colors. So I'm going to choose this setting here. This hole here. I'm going to just make an arc. My staple's getting in the way. Keeping your pencil in that same setting, go over here to B and put your brad on B. Hold the brad in place and then make another arc. And so X marks the spot. So you're going to put a point here and you'll label that point P as in Paul. And then taking your straight edge, you're going to connect Y to P as a ray. And this should be your angle bisector, and we're going to check it with our protractor to make sure. So the original angle has a measurement of 120 degrees. I'm reading the inside of my protractor. So if this angle is cut in half, that means the smaller angle, I'm going to get that glare off of there. There you go. And that means that the smaller angle from here to here must only be 60 degrees. And as you can see, it's hitting there, just a degree shy of 60 degrees. So we did a pretty good job of bisecting that angle. So now we've got this angle here is congruent to that angle there. And that's it.